this lesson, you will learn how to simplify rational expressions. Let's take a look at some basic examples to help you better understand this concept. In these two problems, we have 5x divided by x, and then 28y divided by 4. Now, this type of problem you've actually seen before, but may not remember. In this case, notice the numerator and the denominator are both monomials. Remember, monomials means there's one term. When there are monomials, you can simplify the expressions by looking at the coefficients of the x, which in this case is just the 5, as well as the x's. So in this first problem, because the coefficient of the x in the denominator is a 1, 5 divided by 1 is just 5, so the 5 will not change. However, the x's, because their exponents are 1, and if I would have just given you x divided by x, and if I could put the 1's there, you would subtract those exponents, giving you x to the 0 power, or just 1. Another way to think about it is anytime you have a letter or number over itself, so anything divided by itself obviously always equals 1. So what you can do in this case, because of the 5, is just simply cross out the x's, which leaves you with just the 5. The second problem is similar, but a little different, because in this case there are two numbers rather than two variables. So the numbers you're going to just divide, which would equal 7, and then the variable will remain the same because it has no other y to simplify with. So in this one, the problem simplifies to 7y. So that's a basic introduction to simplifying. Now in both of these cases, the numerator and denominator were monomials. Let's take a look at what would happen if one of them was not a monomial. So in this case, and in case you can't read that, this right here is an a. It just didn't come out too good. So it's really a minus 8 divided by 4. Now I'm going to put a parentheses around anything larger than a monomial, just to kind of so that it stands out. Now if you have a binomial in either the numerator or denominator and a monomial in the other, what you're going to do is you're going to look at the binomial and see if you can factor out the GCF, greatest common factor, of the terms. But notice for the a and the 8, there is no greatest common factor, which means nothing can be done with this binomial. So if you have a problem with a binomial and then a monomial, but the binomial cannot be further factored, then actually this is already fully simplified. So you cannot do anything more with this problem. Now, before I move on to the next problem, one thing I do want to note, the biggest mistake made in this is that students think that you can divide the 8 and the 4. But with binomials, the reason I put them in parentheses is because the 8 is grouped with the a, so it cannot be isolated out and be divided by the 4. It must stay with the a. So a monomial can only be simplified with another monomial. And since we have a binomial over a monomial, you cannot mix the two together. The same thing is true with this second problem. Although it looks like we could just cross out those x's, we cannot, because we can't do that unless the denominator was a monomial. And I'm going to go ahead and put parentheses around it to show you. First of all, if you tried to factor out a GCF of x and 3, there would be none. So you can't do any factoring. So at this point, you can just simply recognize that you have a monomial in the numerator and a binomial in the denominator, and monomials and binomials cannot mix unless you can factor out a GCF, which you cannot in this problem. So again, in this problem, it's also fully simplified. So I wanted you to see that first. Whoops, simplify. Before we move on to a problem that you can actually factor to simplify. Now in these problems, the factoring is already done for you, just so you can see what it would look like. So in this first problem, we have 4 times the quantity x plus 2. So here is our binomial in the numerator. Then we have x plus 2 in the denominator as well. Now, because they're both binomials and they are identical, remember the rule. Anything divided by itself equals 1. So they can actually cancel out because there's a 4 here. If there was no 4, I would just write an answer of 1. But because there is, it's the same thing as saying, okay, I'm going to multiply 4 times 1. So my final answer is simply 4. So this rational expression simplifies to 4. In the second problem, notice you have a monomial here and a monomial here. And a monomial can only be simplified with another monomial. So if I isolate that out, this is what you have for your monomials. Now if I put a little 1 for the exponent in the denominator, and we subtract those exponents, 2 minus 1 is 1. So it's really just x to the first, or x. Okay, so that's going to be simplified. I'm going to cross those out and just put an x in the numerator. The reason it goes in the numerator is because it goes where the larger exponent of the two x's is. Now, we've got an identical binomial, the 5x minus 1 and the 5x minus 1. So those can be canceled because, again, anything divided by itself equals 1. So we're going to cancel that out. So what I have left is I have an x in the numerator and I have an x plus 3 in the denominator. So let me write that out. Now, can I do anything at this point? Hopefully you recall from the last page that a monomial and a binomial can't mix. And the x plus 3 doesn't have a greatest common factor, so this would be as far as I could take the problem. So this would be my most simplified answer. Okay, in this problem, we have two monomials, so we can work with those. Then notice the trinomials, x squared plus 6x plus 5 match. So again, you can only, with binomials and trinomials, the only way they can be canceled is if they're exactly the same, because they would equal 1 when you divide. So these two can cancel. So what I'm left with is just the monomials. Now in the denominator, I'm going to put a 1 with the x. Now the numbers, the 12 and the 4, you're just going to divide. Just pretend the variables are not there. And if you were just given the problem 12 over 4, hopefully you would recognize you would divide those, which would give you 3. For the x's, you're just subtracting those exponents, and it's x squared, which will go next to the 3. So this problem simplifies to 3x squared. Now, in this one, we're going to look at the first problem. Notice the 18 and the 2 are both monomials. So those you just divide, which gives you 9. Now, do you understand whether the 9 would go in the numerator or the denominator? If not, when you're dividing two numbers, wherever the larger of the two numbers is where the answer is going to go. So 18 divided by 2 is 9, and because 18 is larger, the 9 will go in the numerator. That leaves us with the x plus 2 in the denominator. At this point, x plus 2 cannot be factored any further, and we have a monomial in the numerator, a binomial in the denominator, which means we can't do anything because we can't mix those two together. So that would be our most simplified answer. Now the problem to the right of it is actually the same problem, but I'm going to show you how you can use factoring to further simplify this. A monomial you cannot further factor, but a binomial you may be able to. Okay, so you need to recall what you learned about factoring out the greatest common factor. So hopefully you understand that the greatest common factor of the terms 2x and 4 is 2, because you can divide a 2 out of both. When you do, the 2 comes to the outside, and then you're going to go ahead and divide the terms, and whatever is left will remain on the inside. So I'm going to divide the 2's, which leaves me with the x, and I'm going to divide the 4 and the 2, getting a 2. So what that's going to allow me to do is that the 2 times the quantity x plus 2 is going to replace the 2x plus 4. So I'm going to leave the 18 on the top, but I'm going to factor the denominator to see if that will allow me to reduce this any further. Now notice, the problem I have right here looks exactly the same as the one we just did, which was my point. Okay, so now from here you should know what to do. I just wanted you to see that many times the rational expressions will require factoring before you can reduce it any further. So now, just like the last problem, I would divide the 18 in 2, which is 9, then put the binomial x plus 2 in the denominator. And because I have a monomial in the numerator and a binomial in the denominator, that would be as far as I could go. Okay, let's look at a similar example to that. Okay, notice in this one, the one on the left has already been factored for you. The one on the right has not. So I'm going to show you the one on the left first. Okay, so the one on the left, if you look, we have two monomials, 8n cubed and 4n squared. So let's go ahead and simplify that. Well, 8 divided by 4 is 2, and because the 8 is larger, the 2 will be in the numerator. For the n's, the variables, you're going to subtract those exponents, which will be n to the first. And again, because the exponent in the numerator is larger, the n to the first will also go in the numerator. So what we have now is the 2n in the numerator. I'm going to cross out those monomials because we've already simplified them. And we have this binomial in the denominator. Now, if you look carefully at the two terms, there is no number that divides into both 3 and 10, so there is no further greatest common factor. So at this point, you must stop, because remember, the binomial is stuck together and cannot be simplified with a monomial. Now let's look at the same problem before it's been factored. So in the problem on the right, when you can't see anything to do because you have a monomial on the top and a binomial on the bottom, you immediately look to factor out of GCF and try to create a monomial so that you can simplify it with the 8n cubed. So over to the side, I'm going to put the denominator, which is the binomial. And then I'm going to factor out the GCF. So first, you have to think of a number that divides into both 12 and 40, the largest number. And once you do that, you'll realize it's 4. For the variables, the first term has 4 n's, the second one has 2. So you're going to pull out how many they have in common, and they have 2 in common. So we're going to put n squared next to the 4. So we're going to take the 4n squared out, then we're going to simplify the rest. So going back to the first terms, 12 divided by 4 is 3. Then we'll subtract the exponents of the n's, and that will be n squared. We will then divide the 40 and the 4 and get 10, and the n squareds will cancel. So the denominator is going to simplify. I'm going to keep the 8n cubed on top, and then I'm going to move the factored form of the binomial to the denominator. And now that should look just like the original problem that we did to the left. So now you would just simply simplify the monomials, giving you 2n in the numerator, and then keep the 3n squared plus 10 in the denominator. So again, your answers should match for both the left and right problem. Okay, let's look at the problem on the left on this slide. Now notice on this one, you've got 3 binomials. None of them can be factored any further, so you want to look for matching binomials, because the only way binomials can cancel is if they have an exact match. So you can see you have an x plus 3 in the numerator and an x plus 3 in the denominator, so those cancel. So you're left with x plus 2. Now over on the right, notice we have a trinomial in the numerator and a binomial in the denominator. So again, because one's a trinomial and one's a binomial, there's nothing we can do unless we can create matches using factoring. The bottom, the x plus 3, has no greatest common factor, so we're stuck with that. But the numerator, x squared plus 5x plus 6, we can factor. So to recall how to factor that, you're going to find the factors of 6, the numbers that multiply equal 6, so 1 times 6 and 2 times 3, and choose the pair that add up to the middle number, which is the 5. So the only option is the 2 and 3. So we're going to split the x squared up, 1 in each parenthesis, and then we're going to pull the factors, the 2 and the 3, into the parentheses, and it does not matter which one goes where. They're both positive, so we're going to use plus signs. So we just factored the trinomial in the numerator to create more binomials so that we could try to find a match so that we could cancel to simplify. So the x plus 3's match, and the only thing we have left is the x plus 2, which should be the answer because, again, the left side and the right side should match here, which they do. Okay, now here's one that I didn't factor for you at all. We're going to do the whole process together. Okay, we have a trinomial in the numerator and a binomial in the denominator. So what kind of factoring can we do? There are different kinds. So let me pull over to the side the numerator. We'll start with that. Now the first thing you should always look for, whether it's a binomial, a trinomial, or anything larger, is you should look for a greatest common factor. Now, because the first term has a 1, there is no number that divides into 1, 9, and 14 except 1, which would not change anything. So we need to ignore the numbers right now. However, the variables, we have 3 x's in the first, 2 in the second, and 1 in the third. So they at least all have 1 x in common. So the greatest common factor of the 3 terms is simply the x. Now we're going to divide that out of each of those to find what remains in our parentheses. So just simply subtract the exponents. So our first term will now be x squared, our second term will be 9x, and our third term will be 14 because the x's will cancel. So that's going to be our numerator. So let's move that over. Now before I go to the denominator, let's continue to look at that, however. We have this trinomial in parentheses. Can that be further factored into 2 binomials? Well, let's see. We'd have to figure out factors of 14 that have a sum of 9. So we've got 1 and 14 and 2 and 7, and notice 2 plus 7 is 9. So that does break down further into 2 binomials. So let's go ahead and write it as x times the quantity, x plus 2 times x plus 7. Now let's move to the denominator, x squared minus 4. Now let me draw a line here. Now x squared minus 4, we want to write it as a trinomial since it has the x squared. That's our clue that maybe we can factor this. So we're going to put a plus 0x in the middle and then a minus 4. And see if we can factor it into 2 binomials. So we need factors of negative 4 that have a sum of 0. So we have 1 times negative 4, we have negative 1 times 4, and negative 2 times 2. And notice negative 2 and 2 have a sum of 0. So this does in fact break down into 2 binomials using factoring. So we're going to move x minus 2, x plus 2 into the denominator. And now we have something to work with. The x in the numerator is the only monomial, so we're stuck with that. But for our binomials, you're going to look for matches, and we have 1 match. The others do not match, so we have to leave those alone. So when we write our answer, in the numerator we have the x times the x plus 7, and we'll just leave it like that. And in the denominator, we only have the x minus 2. And that's as far as we can go. Because remember, the binomials are stuck together and cannot be simplified if they don't have a match. Okay, this is the last problem for this lesson. X minus 6 over 6 minus x. Notice those are both binomials and they look very similar. The only thing different is in the numerator, the 6 is negative, and in the denominator, the x is negative. So the question is, could we do any factoring so that we can create matching binomials? And we can. In either one, in fact, but I'll choose the denominator. So over to the side, 6 minus x. When you simply have, when the binomials are similar and the only difference is their signs, what you want to factor out is a negative 1. And that's going to flip the sign to the opposite term. So when you factor out the negative 1, it needs to stay. It just comes to the outside. And then we're going to divide the 6 and negative 1, so we'll have a negative 6. Then we'll divide the negative 1 and negative 1, which is a positive 1, or positive x. Now these two can be flipped around. So if you flip them around and put the x first and the negative 6 second, now we have the x minus 6 that we want. So let's bring that back into the problem. So we already had the x minus 6 in the numerator, and now we're going to put the negative 1 times x minus 6 in the denominator. Now we have a binomial that matches, so we can cross that out. And technically what we're left with, if we have nothing left in the numerator, that means there's a 1. And we have a negative 1 in the denominator, but when we divide that, we get negative 1 for our answer. So that completes the lesson on simplifying rational expressions. Good luck with this lesson.